Hey guys, Justin here from First Updates Now, checking in from the Peachtree District Championship. I'm here with 1261, the Robo Lions, who are having a breakout season with 2 qualifier wins. I've got Kevin, Jonathan, Justin, and Caduce here to talk about their intake, how it feeds up into their whole shooter and amp mechanism. They're going to run through a function check, all that and more here on Behind the Bumpers.
This video on fun is brought to you by viewers like you and also in partnership with the following. Discover how Kettering University students engineer their success with Kettering's amazing co-op employment programs where students earn great pay and gain valuable experience. Those accepted into Kettering University can apply for a robotics scholarship providing up to an additional $5,000 a year in tuition assistance. Head on over to kettering.edu/first to learn more and apply. Support Fun's content creators when you sign up for a membership on YouTube Join. You'll get access to special perks like emotes, loyalty badges, and Fun members will even get early access to our scheduled videos and more. 100% of this revenue will go back to our correspondents to help recognize their efforts. Click the join button in any YouTube video to pledge your support.
All right, so I'm going to hand it off here to Kevin. Get us started off.
All right, so my name is Kevin. I'm Team 1261's mechanical lead. And what I wanted to start off with is our under the bumper intake. So during the strategy meeting that we had at the beginning of the year when kickoff was, we decided that under the bumper intake would be the move for this game due to the hard hits and the hard collisions. And so far throughout our past 2 events, we realized that that was the case and that going under the bumper was the method for this game. So if you would like to come back here to take a look at the under the bumper intake, we were inspired by Team 95's and their extension of the under the bumper intake from the frame perimeter. In addition to that, we also looked at Team 4522, Team Scream, and we liked their roller geometry in which helped us get our under the bumper intake design. So you can see we have a front roller here that's driven by this Kraken, and then we have 2 back rollers that is driven by another Kraken. So yes, we are using 2 Krakens for our intake. And then as the note feeds into the intake, it kind of shoots up into our indexer, which Jonathan here can talk about.
So our indexer here, we have it at an angle whenever we're intaking, and we basically run it with these dead axle rollers. The rollers spin, but there's a shaft in the middle that acts kind of like a standoff. And then this is driven by, this Kraken right here kind of runs this whole entire system. And we have pulley, and then we have our, which we kind of decided to do here because there was no room for like gears and stuff. We didn't want a gigantic gear.
An infinity belt?
Yeah, polycord infinity belt. So that's how we ran our indexer.
Awesome.
All right, so for the shooter, after it goes in through the indexer, it goes through the 2 sets of wheels. You have the top, the right side of the wheels driven by this motor, this Kraken right here. And then you have this other motor from this side driving the right set of wheels. And then for the amp scoring mechanism, the indexer will feed it through the whole system, and then it'll come essentially bend a 90 degrees, and it'll come out shooting a shot from the amp, and then for the shot into the speaker, it comes out of these 2 sets of wheels.
So I saw a lot of teams had these shooter wheels like this mechanically linked. Did you find any advantage from not having that?
So originally from our V1 shooter, which we have right here, we had them mechanically linked, and originally when we had them mechanically linked, we saw a slight difference in how the shot comes out for the note. Usually we have to tune it to where the 2 motors have to drive at the same speed. If that is not possible, then the note will either flip up or flip down, which was not really what we wanted. And so we chose to go with a new design of a shooter, V2 shooter, where we have two gears here driving the right side, and then it actually adds extra spin for the shot, making it more linear and being able to shoot further from to the speaker. Yes.
Cool.
So for our shooter, we actually run our 2 sides at a 3 meter per second differential to really get like a nice spin on the note to get it flying as flat as possible. I think you can see we have 3 limelights mounted, 2 on the front, 1 on the back, and that allows us to have almost complete awareness of where we are on the field, which is very useful for our auto aiming. Because what we do is we use our robot pose to not only automate the aiming of the arm towards the speaker, but also automate the aiming of the swerve, so that it'll automatically align to the speaker and make it a lot easier on the driver to be able to do those kind of things. We also have our intake set up so that it can almost feed into the arm at any position, which allows us in autonomous so that there's no delay between when we pick up the piece and when we shoot. If you actually notice in our autonomous, we hit the piece and then we immediately shoot it out in the near side pieces.
Right.
So because it's like a constant flow, there's almost no pauses in our autonomous.
Is there any way you can demonstrate that?
I can do a quick systems check. So enabling, and I'm gonna start by running our intake. Okay, and then I'll run our shoot. So the arm's gonna move and spin up, and then we fire. And I can also demonstrate our amp mechanism. So the arm goes up, and then you'll see the note kind of curve through and come out the back, like this. And then, anything else you want to demonstrate?
Yeah, and then for this game, we decided that trapping was not our main priority, because we knew that if we were a fast cycler and we were able to pick up the notes right off the ground, we'd be able to solo the 18 notes for the RP. But now that since it's DCMP, of course that note threshold is increased. And so at the beginning, we just decided that we wanted to be a fast cycler instead of getting the other ranking point through the trap mechanism. So we just decided we only wanted to climb for this season.
Are these custom bearing blocks on your climber?
Yes, these are custom bearing blocks because with the original climber in the box, they had springs on both sides, and then due to packaging constraints, we only needed the spring on one side. So the whole entire climber in the box mechanism is custom.
Very nice.
Yeah, so for this season, we knew that we wanted to build really simple. Last year, we went with a 4-foot arm that was driven by a live hex axle. And what we saw there was that there's a lot of backlash in the arm, and we could not get the arm to be in the correct position where we wanted to. So this year, we learned from our mistakes in the past year, and we decided to go for a dead axle system. This dead axle system for the pivot was greatly inspired by the West Coast products, the competition concept, and it uses the West Coast Spline XL, and then it's driven by this 35 chain, and our gearbox is right here, and we have a it's driven on this bushing that's connected to the arm, and with this we have our own tensioning system as well, because it was tough to fit in an inline tensioner, so we can adjust this to go push the bearings in or out to tension the chain. And with this setup, we have very, very little backlash compared to last season, enabling us to be able to shoot from further distances since our arm goes to the correct angle.
All right, awesome. Well, thank you guys very much. Be sure to watch out for this team at the World Championship.
This video on fun is brought to you by viewers like you and also in partnership with the following. Discover how Kettering University students engineer their success with Kettering's amazing co-op employment programs where students earn great pay and gain valuable experience. Those accepted into Kettering University can apply for a robotics scholarship, providing up to an additional $5,000 a year in tuition assistance. Head on over to kettering.edu/first to learn more and apply.